Good evening, students. Today we are going to discuss chemical equilibrium JEE NEET questions from 21 to 32. So this will be our last part for the numericals. So what is question number 21 here? They have given hydrogen iodide HI was heated in a closed tube at 440 degrees Celsius till equilibrium is reached. At this temperature, 22% of HI was dissociated, and they are asking what is equilibrium constant? Nothing but Kc. First and foremost thing, write the equation what they have given here. Hydrogen iodide was heated, so hence we can write like this: 2Hi. So equilibrium H2 and I2. So this is your equation. So let initial concentration, because they have given 22% is dissociated, let us take that. The initial concentration is 100. It is easy for you to calculate if you take 100. Next, since 22% is dissociated, so we can write the concentration at equilibrium. So let us write the concentration at equilibrium. So we can easily write that because 100 and 22 is dissociated, we can write 100 minus 22. So therefore you get at equilibrium the concentration is 78. Now here 22 is dissociated equally, hence we have 11 and 11. Now we got the concentration. So what is the formula here? Kc is equal to the concentration of products H2 into I2 divided by the product, here the coefficient is 2. Therefore we write it as concentration of Hi square. Substitute the values here. Concentration 11 into 11 divided by 78 square. I have already calculated this and I got a value of 0.0199. So answer is this. Hope you have understood this very simple calculation. Copy this and let's move to question number 22. Now question number 22, try to understand the question. When CO2 is dissolved in water, we get this equation, that is CO2 plus 2H2O, hydronium ion plus bicarbonate ion, for which equilibrium constant they have 3.8 into 10 power minus 7 and the pH measured was 6. They are asking the ratio of bicarbonate to CO2 concentration. Now first and foremost thing, what is given? pH is equal to 6. Now if you know pH, negative log of HCO3 minus, so we can write like this. So HCO3 minus concentration, if you calculate, it will be 10 to the power of minus 6. If pH is equal to 6, its concentration will become 10 to the power of minus 6. It is understood. Now, what is the equation? CO2 plus 2H2O gives hydronium ion and bicarbonate ion. For this, let us write equilibrium constant Kc. They are asking to find out the equilibrium constant here. So which is given as 3.8 in 10 power minus 7. So the concentration of products divided by the concentration of reactants, CO2 concentration into H2O square, because it's liquid, you can ignore the concentration. What is Kc now? 3.8 into 10 to the power of minus 7. Hydronium ion concentration H3O plus, hydronium ion concentration is 10 to the power of minus 6 into HCO3 minus by concentration of CO2. Now we need to find only this ratio of this. So send 10 to the power of 6 to the other side, what you get? 3.8 into 10 power minus 7 divided by 10 to the power of minus 6. Now if you cancel this, you will get 10 to the power of minus 1. So therefore a ratio of bicarbonate to the concentration of CO2 is nothing but 3.8 into 10 to the power of minus 1. So just find out So we got the answer as A. Hope you have understood this very simple question. First you need to find out the concentration of H plus R, H3O plus ion, nothing but if pH is 6, you will take it as 10 power minus 6. Substitute this and you will get the ratio. Copy the solution and let's move to question number 23. Next, question number 23. For equilibrium 2 NaCl gives 2NO plus Cl2. They have given equilibrium constant 3.75 into 10 to the power of minus 4 at 1069 Kelvin temperature. They are asking find the Kp. We already know the relation. Kp is equal to Kc into RT to the power of delta Ng. First, let us calculate delta Ng for this. What is delta Ng? Number of moles of gaseous products. Number of moles of gaseous products minus number of moles of gaseous reactants. So this is our formula for delta Ng. Earlier also we have done numericals based on this. Now, how do you find number of moles of gaseous products? So product is 2 plus 1, nothing but 3, minus for reactant, number of moles we have 2, so 3 minus 2. So therefore delta Ng, what you get? We get 1. Now substitute the values here. What is Kc? 3.75 into 10 to the power of minus 4. Now into, so R you know 0.0821 into temperature is 1069 to the power of 1. So upon calculation, I already calculated, so I will get an answer 0.033, so Kp. So this will be your answer. Copy the solution and let's move to question number 24. Next, question number 24. At 30 degrees Celsius, gaseous mixture of N2 plus O2 gives 2NO has 56 grams nitrogen, 128 grams of oxygen and 120 grams of NO. And what is the pressure given? At equilibrium, the total pressure 1 atmosphere. Now they are asking calculate the value of Kp. Now first let us write the equation. N2 gas plus O2 gas gives 2NO gas. Now before you start, so we need to find out Kp. Therefore partial pressure we need to calculate. What is the formula to calculate partial pressure? Partial pressure is equal to mole fraction into total pressure. First and foremost thing is we should know the method to calculate partial pressure. Why you need to calculate partial pressure? Because you know the value Kp is equal to partial pressure of products divided by y I wrote p square, you know coefficient is 2, therefore p square, and partial pressure of N2 gas into partial pressure of O2 gas. So you have this two formulae. Now first and foremost thing, let us write initial number of moles. Initial number of moles. And what is the formula to calculate number of moles? Mass by given mass by molecular mass. So that we know. So let us write formula given mass by molecular mass. Let us calculate for N2. What is the mass given? 56. And what will be the molecular mass? So you know that it is 28. So first one 56 by 28, mass by molecular mass. For O2, 128 divided by molecular mass, you know 16 plus 16, 32. Next for NO, the mass is 120 grams divided by molecular mass, nitrogen 14, oxygen 16, therefore it is 30. Now calculate this 28 and 56, you can take it as 2. This is 4 and this is 4. So we have number of moles 2, 4 and 4 at equilibrium. Why you have calculated number of moles? Because you know to calculate the mole fraction you need this. Next time. So total number of moles is equal to, you have to add this, nothing but 2 plus 4 plus 4, which is 10. Now mole fraction. mole fraction. Earlier, you know what is mole fraction? If you are calculating mole fraction of A is equal to number of moles of A by total number of moles. So this is your formula to calculate mole fraction. First and foremost thing, how to calculate the mole fraction for N2. We know number of moles is 2. And what is the total number? 10. This is 4 by 10. This is 4 by 10. Hope you are able to understand stepwise I am calculating. Now what is 2 by 10? 0.2. 4 by 10, 0.4. 4 by 10, 0.4. So this you got mole fraction X. Now you got mole fraction. What is total pressure? It's 1. So hence we can find out the partial pressure. You can calculate it separately. The partial pressure of NO, first and foremost thing. So 0.4 into 1, nothing but 0.4. So you can write the unit also, atmosphere. Next, partial pressure of N2 is, mole fraction is 0.2 into total pressure 1, therefore you get 0.2 atmosphere. Next, what is the partial pressure of oxygen? You know number of, that is mole fraction is 0.4 into total pressure 1, hence you get 0.4 atmosphere. Now you have calculated the partial pressure and substitute in the value of Kp. So what is Kp? Kp is equal to, you know, P square NO. What is the partial pressure of NO? 0.4, therefore you have substituted the value, divided by partial pressure of N2, how much you got? 0.2. And last, partial pressure of oxygen, how much you have? 0.4. Cancel 0.4 and this will be 2. Therefore Kp is equal to 2. Hope you have understood this. Applying this formula, you have calculated the value of Kp, nothing but 2. Answer is B. Hope you have understood this. Copy the solution and let's move to question number 25. Next, question number 25. 1 mole of PCl3 with 2 moles of Cl2 were placed in 3 liter vessel and heated to 400 Kelvin. When equilibrium was reached, 0.7 moles of PCl3 remained. They are asking find the Kc for this reaction. Now first and foremost thing, write the equation. PCl3 plus Cl2 gives PCl5. Fine. Now they have given initial number of moles, so let us write this. Initial number of moles. PCl3 is 1 and chlorine they have given 2 moles, product is not formed. Next, at equilibrium, number of moles. What they have given? They have given that in the equilibrium 0.7 moles of PCl3 was remained. Fine. So now if it is remained means what you can say, so you know the values here, x and this one is 2 minus x and this is 1 minus x, and given 0.7 moles PCl3 is remained. That means what is 1 minus x? Therefore 1 minus x is equal to 0.7. Find out x. Send 0.7 to this side. 1 minus 0.7 is equal to x. Therefore x is nothing but 0.3. Hope you have understood this. Now we can convert this. 1 minus x nothing but 0.7. 2 minus x 1.7 and x is nothing but 0.3. Already you have taken. Now, so what is the concentration? Concentration formula, you know, number of moles by volume. We need to find out the concentration, then only you will get the value of Kc. Hope you are clear up to this. Now what is number of moles? 0.7. What is volume? 3 liters. Therefore this will become 0.7 by 3. Concentration of PCl3 is 0.7 by 3. Now concentration of chlorine is 1.7, is number of mole, volume is 3 liter. Now this X is 0.3, number of moles by volume is 3. Hope you have understood, we got the concentration. Now, how do we calculate Kc? The concentration of products by the concentration of the reactants, nothing but PCl5 concentration by PCl3 concentration into Cl2. So we already know the formula. Now substitute, what is PCl5? 0.3 by 3 divided by, see, you need to write the unit also. We can write the unit, nothing but mole per liter. Why I am writing? Because here unit is also mentioned. Divided by, now you know that concentration of PCl3 is 0.7 by 3. Substitute that, 0.7 by 3, again mole per liter. You can cancel this. Next, this is 0.3 by 3 mole per liter. Hope you have understood this. Now reciprocate this, what you get? 0.3 by 3 into 3 by 0.7 into, for Cl2 it is nothing but, so what is Cl2 concentration? 1.7 by 3. So it is 1.7 by 3 will become 3 by 1.7. Now it is in the denominator, mole per liter. If it comes to the numerator, it will be written as liter per mole. So with the unit you can understand that either the answer will be C or A. Why? Because unit is liter per mole. Now calculate this. On calculating, already I have done this, we'll get 0.76 liter per mole. This is the value of Kc. So answer is C. Hope you have understood this. Copy the solution. A very simple question. First you need to write initial number of moles for this, and equilibrium they already mentioned it as 0.7. So based on that you have calculated, and write the formula for Kc and substitute your concentration. So you have applied two formulae. One is concentration, number of volume, that is number of moles by volume, and Kc, you know, the concentration of products by the product of the concentration of reactants. Copy the solution. Let's move to question number 26. Next, question number 26. PCl5 dissociates with this equation. If total pressure of reaction mixture is P and degree of dissociation of PCl5 is X, calculate the partial pressure of PCl3. Very simple question. First thing, write the equation. PCl5 gas gives PCl3 gas plus Cl2 gas. Now let initial number of moles. See, initial number of moles you can directly take. This is 1, no product formation. Next, after this, at equilibrium they have mentioned that the dissociation of PCl5 is X, so that means X moles are formed, and this you can write 1 minus X. Total number of moles. We are following the same steps, no change. 1 minus X plus X plus X minus X plus X gets cancelled, therefore total number of moles what you have, 1 plus X. Next, see, for this, to find out partial pressure, what is the formula? Earlier question we have done partial pressure is equal to mole fraction into total pressure. Mole fraction into total pressure. Apply the same thing. To find this mole fraction, let us take mole fraction. You know the formula, what is meant by mole fraction? If at all you take Na by total moles. So Xa is equal to, this is one formula what you apply. Therefore, how many number of moles you are having here? This is 1 minus X. See, now the question is only PCl3, so let us limit ourselves only to this. So x by total is 1 plus x. So mole fraction, you got x by 1 plus x, and they have given total pressure is taken as P. Now substitute this. The partial pressure of only PCl3 they asked, hence we are calculating only PCl3. Mole fraction is x by 1 plus x into total pressure is P. Just check out. Answer is option A. Hope you have understood this. Copy the solution and let's move to question number 27. Next, question number 27. Equilibrium constant Kc for 3/2H2 plus half N2 gives NH3. So this is initial one, or you can say that K1. So they have given first equilibrium constant K1 and K2 is the equilibrium constant at these temperatures. So this is nothing but you can calculate that. So at this temperature it is K1 and at 400 degrees Celsius it is K2. Now they are asking calculate heat of formation, nothing but delta H. So to solve this question you need to apply Van 't Hoff's equation. Van 't Hoff's equation. So what is Van 't Hoff's equation? Log K2 by K1, nothing but second equilibrium constant by first equilibrium constant, is equal to delta H by 2.303 R into T2 minus T1 by T1 T2, where T and you can calculate T1 and T2 in terms of Kelvin. First thing, what is K1? They have mentioned 0.0266. What is K2? 0.0129. Hope you are able to follow. We need to calculate delta H. Next, what is R? If you observe the options they have given in calories, if you take calories, value is 2 calorie per Kelvin per mole, depending upon the unit you have taken the value. Next, what is initial temperature T1? 350 degrees Celsius to convert into Kelvin, add 273. So we get 623 Kelvin. And T2, 400 degrees Celsius plus 273, we have 673 K. Hope you have understood this. Now substitute in the formula log K2. So K2 is 0.0129 divided by K1 is 0.0266, nothing but delta H by 2.303 into 2. And what is T2 here? 673. So 673 minus 623 divided by 623 into 673. Hope you have understood this. I have given the formula as well as I have substituted. Now to find delta H, you can first calculate log value of this. Try to calculate this. I will solve for you. So I have solved this from here. This value is 0.4849. We need to find out log of this. You know the method also characteristic is minus. So here you will get minus 0.3143. So I have done with the calculation of T1 and T2 also. We have 50 by 623 into 673. Now, so to calculate delta H, send this to other side. Now we get delta H in terms of calories minus 12,139. If you convert into kilocalories, you will get minus 12.14 kilocalories. Answer is C. Hope you have understood this. Using Van 't Hoff's equation, we have solved this question. Whenever they give heat of formation delta H, you can use Van 't Hoff's equation. Copy the solution. Let's move to question number 28. Next, question number 28, they have given 3 reactions A, B and C, and they are asking which of the following relation is correct. So the equilibrium constant for first one is K1, second K2, third is K3. What you need to do is you have to find out the relation between these 3 equations. With little practice you will understand See, you have CH4 here and 2H2O. How do you get 2H2O? If you add equation 1 and 2. Here you can observe 3H2 and 1H2. Therefore, you will get 4. So, by observing these equations, we can understand that equation 3 we can get by adding equation 1 and equation 2. Let us try to add that. First, CO plus H2O gives CO2 and H2. Second one, CH4 plus H2O gives CO plus 3H2. Let us try if we get the same or not. So what is required? A CH4, circle that, then CO and CO gets cancelled. So what we get? CH4 plus 2H2O gives CO2 plus 4H2. Hope you have understood this. Now, if at all you are adding the equations, then what will happen to the equilibrium constant? You have to multiply that. Hence, K3 will be equal into K1 into K2. You know the relation, hence we can write like this. K3 is equal to, if at all you are adding two equations, then equilibrium constant must be multiplied, that we know. So what will be the relation here? K3 is equal to K1 into K2. Option B is right. Copy the solution. Let's move to question number 29. Next, question number 29, they gave the mixture of SO3, SO2 and O2 in equilibrium. So what is the volume here? 10 liters. And they have given Kc is 100. For this particular equation, Kc they have mentioned. Two conditions or two questions are mentioned and options also there. First one, number of moles of SO3 and SO2 are same. You have to find number of moles of O2. Second one, number of moles of SO3 is twice SO2. Calculate O2. Now write the equation. 2SO2 plus O2 gives 2SO3. And Kc, you know, nothing but the concentration of products by concentration of the reactants. SO3 concentration square, because coefficient is 2, divided by SO2 concentration square, because coefficient is 2, and O2 is having 1, hence we write like this. So this is Kc. And what is the value of Kc? 100. So you can write here in the place of Kc, 100 is equal to SO3 square by SO2 square into concentration of O2. This we got. Now what they have mentioned, if you take the condition A, number of moles or concentration, you can write like this. SO3 is equal to SO2. Substitute the value of SO2 in this. So therefore 100 is equal to, we can write like this, SO2 square by SO2 square. So what I have done is, in the place of SO3 I have taken SO2 in the same equation into the concentration of O2. SO2 square gets cancelled out. Now you want only O2 concentration. Send this to other side. So concentration of O2 is equal to, this will become 1 by 100, 0.01. And you know an important formula, what is that? The concentration is equal to the number of moles by volume. Now they are asking to find number of moles. So therefore we can write N is equal to concentration into volume. Hope you understood this. Now substitute this and get the formula. Therefore number of moles of O2 is equal to, what is concentration? 0.01. And what is the volume? They have mentioned the volume is 10 liters. So into 10, you will get 0.1. In the first case, you get 0.1. So you may get either first one or this. Now, what is B? They have given that the number of moles of SO3 or concentration is twice of SO2. So we can take like this. SO3 is equal to 2 into concentration of SO2. You can write, substitute in the formula, and what you get? We get Kc, nothing but 100 is equal to, in the place of SO3 you have to substitute SO2 into 2, therefore 2 times the concentration of this, the whole thing square by, here you have SO2 square. Fine, both gets cancelled, and what is 2 square? Nothing but 4. We get 4 by the concentration of O2. Now send O2 to other side, what you get? The concentration of O2 is equal to 4 by 100, nothing but 0.04. Now apply the same formula. Number of moles is equal to concentration into volume. Hope you are able to understand this. I am just substituting the values in Kc formula. So therefore, number of moles of O2 is equal to concentration 0.04, volume is 10, hence you get 0.4. Hope you got this. So what is the answer? In the first case A, you get number of moles of O2 0.1. In the second case, that is B, number of moles of O2 is 0.4. Copy the solution and let's move to question number 30. Next, question number 30, I have solved this. For C2H6, C2H4 plus H2 is formed and Kp is given as 0.05 Pascal. They are asking Gibbs free energy, that is delta G naught at temperature of 627 degrees C. If you know the formula, you can easily calculate delta G naught is minus RT natural log of Kp. Now what is given? Kp 0.05 Pascal. Temperature, you know, 627 degrees Celsius, therefore to convert into Kelvin add 273, so you get 900. And R in terms of unit, you can see they have given in joule per mole, hence R value is 8.314. Now substitute that, and natural log of 0.05 you got as minus 2.9957. Here minus into minus will become plus, and you will get the answer as delta G naught 22,415. So this joule you have to convert into kilojoule, hence you get 22.415. So what will be the value here? 22.4. Answer is B. Copy the solution. Let's move to question number 31. Next, question number 31. I have solved this already. For the reaction 2HA gives H2 plus I2, alpha is the degree of dissociation. Now they are asking alpha and Kp, what is the relation? For that, first write the equation and apply the same thing. Initial moles, we have here 2 moles, product is not formed, hence 0. Next, at equilibrium, you know that alpha is the degree of dissociation, hence 2 minus 2 alpha. Next, what is the total number of moles? You can just cancel this and you get total number of moles is 2, and we already know the formula. Partial pressure is mole fraction into total pressure. Everything we already have solved, hence this is a repetition. So you get the value finally. Next, Kp value, you know, the partial pressure of the products by partial pressure of the reactants, that I have written here. Next, why have we wrote a P square? Because the concentration, or you can say that the number of moles are Hi here. Next, you can substitute the value of Kp like this. So H2 and I2, the partial pressure are this alpha by 2P into this. We will get alpha square by 4 P square, and then for Hi the partial pressure is 2 minus 2 alpha by 2 into P. Hope you are able to understand. I have solved this and substituted. So finally you get Kp is equal to alpha square by 2 minus 2 alpha square. What we do is, we have square on the other side, so send this to the LHS, you will get root Kp. So root Kp is alpha by 2 minus alpha. So nothing but you can just take 2 as common and you get 2 into 1 minus alpha. Send 2 to other side, you get 2 into root Kp is alpha by 1 minus alpha. Now the relation can be this. So 2 into root Kp by 1 plus 2 root of Kp, option D. So copy the solution. Let's move to the last question, question number 32. Now the last question, question number 32, I have solved it for you. A very important question and lengthy question. Now the reaction is acetic acid plus ethyl alcohol gives ethyl acetate plus water, nothing but esterification reaction. In this they have mentioned initial condition, that is 60 grams of acetic acid, they took 46 grams of ethyl alcohol. What is the volume? 5 liter. And now the product you have 44 grams of ethyl acetate. This is the first condition and we can calculate Kc for this. Based on this, they have changed the mass of acetic acid and mass of alcohol remains same, and now they are asking what will be the final mass of the ester. So first and foremost thing, calculate Kc in the given condition, then substitute that and write in the step 2. I have done this. First one, what is the mass given? Acetic acid 60, alcohol 46, and formation of ester is 44 grams. Now what will be the molecular mass? You can calculate. Carbon 12, H is 1, oxygen 16. On calculation you got molecular mass is 60. For ethyl alcohol molecular mass you got 46, and for ethyl acetate ester you got molecular mass is 88. To save time I have solved it already. My target is to give you more number of questions, so this will be your 32nd question. Now what will be the formula for number of moles? Number of moles is equal to mass by molecular mass. 60 by 60, nothing but 1. 46 by 46, 1. And 44 by 88, nothing but 0.5. So you got number of moles. Next, you know the formula for the concentration. Next step, all these already we have done. Concentration is number of moles by volume. So 1 by 5 liter, 1 by 5 liter, 0.5 by 5 liter. So you are going to get the initial concentration. Now, we are having a formula here. If at all you are taking X for this, suppose it is X. Now this is concentration minus X. This is also concentration minus X. And this is also X. And what will be the value here? X value is 0.1. So therefore, this is 0.2 minus 0.1, 0.2 minus 0.1. So finally, at the equilibrium, you are getting the concentration of acetic acid, alcohol and the remaining products. And substitute that in the formula of Kc. What is Kc? The concentration of the products by concentration of the reactants. So finally, Kc value you got 1. So step 1, find the equilibrium constant with the given mass. Now, mass is changed now. So that we will write. Follow the same steps. What will be the concentration here? Number of moles by volume. So you know the number of moles. Mass by molecular mass. So this is also mass by molecular mass. So you get initial concentration like this. Nothing but 0.4. And at equilibrium, let us take the concentration of ester as well as water. You can take, that is nothing but X. So 0.4 minus X, 0.2 minus X. Apply the value Kc, you know, it is equal to 1. And the products X into X, X square, divided by the reactants 0.4 minus X into 0.2 minus X. So hope you have understood up to this. So you get the value of X as 8 by 60. Now how to find number of moles? You know the formula. Number of moles is concentration into volume. What is the concentration? 8 by 60. What is the volume? 5 liter. Therefore, we get the number of moles as 2 by 3. And finally, you don't know the value of mass. Therefore, mass can be calculated like this. Apply the same formula. What is that? The number of moles is equal to mass by molecular mass. How do you get mass? Cross multiply. So therefore, mass is equal to number of moles into molecular mass. So what will be your mass? 2 by 3 into 88, nothing but 58.66. You get 410. That is option D. Hope you have understood this. First step is finding out value of Kc. Second step, change the mass. And you know the value of Kc is 1. So substituting that, you get the finally what will be the mass of ester, that is ethyl acetate formed. So copy the solution. Hope you have understood this question number 21 to 32. Thank you so much.